Assalamualaikum everyone. Today we're going to continue learning about organic chemistry, and the topic that we will discuss today is carboxylic acid and derivatives. Okay, when you heard about carboxylic acid, I'm sure you heard of it back in your high school days, back in your fundamental year. So I think I would like to view this first. Okay, alright, now these are some of the things that you can find in real life, that you can find around you that actually contain carboxylic acid. So you see three photos here. The first one is ant. Okay, second one is actually vinegar or cuka, and the last one is butter. Okay, Malaysian can call them margarine or mentega. Okay, so well, you know, they all contain carboxylic acid, and let me show you. The first one, ant, even the name of formic acid is derived from ant. The ants contain formic acid, so the formic acid actually looks like that. Okay, so this is formic acid. It is a common name. Okay, but the IUPAC name for this compound is simply, you see, there's only one carbon there, so it is met. Okay, met. And then the back of it, because it is an acid, so metanoic. Okay, it has the oic and acid. The second one is vinegar. Vinegar contains acetic acid. Okay, it's about, I think, 90% water, 10% acetic acid, if I'm not mistaken. I could be mistaken, okay? But it definitely contains acetic acid. Again, this is a common name or a famous name of vinegar, of acetic acid, okay? But the IUPAC name or the drawing of the structure looks like that, okay? We have CH3 there instead of H instead of hydrogen. We have two carbons now. Now you know that if there's two carbons, you say at, right? And then you are going to follow them with ethanoic acid. Okay, what about butter? Butter actually contains what we call as butyric acid. When you heard about all this name, you might be, well, this could be your first time hearing about it, but when I draw you the structure, okay, you can name, you know, the compound. It's just that I want you to relate compounds and their purposes in our everyday life. Okay, butyric acid also looks something like that. Okay, then you have CH2, CH2, CH3. Okay, so we have 4 carbons. So its name is going to be butanoic acid. Okay, that's it for acids. Okay. Now for the IUPAC naming, now we're going to learn a lot of it. Okay, we're going to learn a lot of it. Okay, so the first one we're going to learn about is acid. So I've introduced you to both of these. Okay, how are you going to name them is basically where is your first and foremost, you have to calculate how many number of carbons that you have, and then of course for the oic acid, for this part at the end here, okay, you don't need to write where. You know, with alcohol you have to write where, say butan 2 ol, butan 1 ol. Okay, in the case of acid carboxylic, it is the same with aldehyde. You don't need to put in the numbers, okay, because it always have to be at carbon 1 here, you know. So and then it is the same thing. For example, here you are going to propanoic acid, because essentially we have 3 of it and we have substituent at carbon 2. Okay, and the next thing is for example, you see other group present in it. Okay, for example, we have NH2, that stands for amine. Of course, it sits in priority lower than carboxylic acid, so you're going to name it as 4-aminobutanoic acid. Okay, and acid can also be present in what we call as aromatic compound, or with the presence of benzene. Okay, again, you will find this in the topic of benzene. So these, when a benzene is attached to COOH, okay, when a benzene ring is attached to a COOH, then you call them benzoic acid. From then on, everything should be named as benzene naming. Okay, for example, you write para and auto. We have seen it in the topic of alcohol. For example, in phenol, we have seen this in acetaldehyde, in the topic of aldehyde. Okay, they are all not acetaldehyde. I think it's benzaldehyde. Okay, they are all contain a benzene ring. Okay, and auto, if you go back to my previous talk, auto means that the substituent will sit next to the functional group. Para means the substituent will sit in front of it, like the opposite of the functional groups. Okay, but not only that, carboxylic acid may also contain other functional groups such as alkene. You see this example here. Okay, you see that example there. You have acid, at the same time you have alkene. Now alkene is lower in priority than acid, so you just have to number it. Okay, in this case, okay, we have 6 carbon, so it is hex. The most common mistake that student did was not actually calculating this particular carbon right there. Okay, that's why then they just end up with less of 1 carbon. Okay, so in the case of hexanoic acid, again, as you all know, I prefer the new IUPAC because essentially we will tell where is our in. In this case, our in is sitting at carbon 3, hex 3 enoic acid. So in the case of drawings like this, you know, it's already showing you that it wants you to identify what is the geometrical isomerism in it. So in this case, it's an E. Okay, go back to the topics of alkene, and we have seen this already. Okay, now what if we seen something like this? So this is called cyclohexane carboxylic acid, and you're going to number it as per example there. Alright, so essentially the boiling points of carboxylic acid will be higher than alcohol, will be higher than many other functional groups. Okay, because even alcohol is already high because it has the hydrogen bonding, but more than that, carboxylic acid can make a dimer, or it has a higher chance of not a high chance, but the hydrogen bonding is strongest. Alright, now how do you make carboxylic acid? We essentially have seen this over in many topics prior to attending to this particular topic. Okay, we have seen this in the topic of alcohol, we have seen this in the topic of aldehyde, we have even seen this in the topic of alkene. So these are the reviews of the synthesis. Firstly, we can get acid through oxidation of primary alcohol and aldehyde with chromic acid. We can cleave alkene using potassium permanganate, hot and concentrated. We can ozonolize alkyne. Okay, we have to ozonolize alkyne in order to get carboxylic acid. We can also change the alkyl parts of the benzene containing compounds, and then we will reach chromic acid. The first one is oxidation of primary alcohol or aldehyde. We have seen this. Okay, if you use chromic acid, essentially O here meaning oxidation, O there meaning oxidation, and oxidation reagent that we can use is chromic acid. You will use sodium dichromate with usually it is written like that. Okay, this is an arrow. So yeah, if you oxidize primary alcohol using this reagent, you will get acid. If you oxidize aldehyde with this reagent, you will also get acid. Okay, so go back to the topic of aldehyde. How are you going to stop it at aldehyde? Okay, so you know, if you use PCC, it will stop at aldehyde, but if you use sodium dichromate, you will straightforwardly get the carboxylic acid. Right, and then for oxidation of alkene and alkyne, okay, you will for alkene you will use hot and concentrated alkene, okay, to cleave it. Okay, go back to the topic of alkene. We have seen this, okay, but for alkyne you can either use potassium permanganate or ozonolysis, because both of the structure will yield carboxylic acids. Okay. Now, these are the case of alkene cleavage. Okay, so as you know that in even the previous videos have shown you that with concentrated and hot potassium permanganate, if you got a ketone, then your product will end there. You will just get ketone. But if you say you get aldehyde, that will be not your final product. You will straightforwardly get acid because of the presence of potassium permanganate. Now, what if we cleave it using ozone or potassium permanganate for alkyne? Okay, for alkyne is a different thing altogether, because for alkyne we are going to cleave it and the product will always be carboxylic acid. Okay. So this you've been given an example there. So essentially what you do is you just cleave this entire part and add COOH in it. Okay. Now for side chain of alkylbenzene, for me these are among the most amazing chemical reaction, in addition to Wittig reaction, in addition to Clemensen reduction. This one, alkylbenzene and to carboxylic acid, whereby what you do is you are going to whatever side chain that you have here, CH3 very long one, for example butyl, for example, everything will be turning into COOH. You will see this again in the topic of benzene. Okay. Now, reaction review for carboxylic acid. Actually, before I even go there, let me see. Okay, the reason why I go to esterification first, because this is something that you have seen already. Okay, most of you have encountered this back in your high school year or your fundamental year. Okay, they are being called as Fischer esterification, because what you are using is you are using carboxylic acid and you are using alcohol. So what you are doing is you are going to take this part, okay, this part here, and then merge it with this part there, okay, and then you will get your alcohol. Okay, essentially what you do is your the lone pair of electrons in your carbonyl, okay, will attack the ions that was present in the reactions, okay, in the proton. Okay, then after that, lone pair of OH in the alcohol will straightforwardly attack the carbon that attached to the carbonyl as well. Then to stabilize everything, the electron in the middle have to be moved to that protonated oxygen. Okay, and then more moving or pushing of electron will be completed, and then your final product will be ester hydrate. Okay, and then after that, your to stabilize everything, you are going to react it again, whereby the end products of yours will be ester. So try to be, this is a simplified slide. You can further read it in the notes of yours. Okay. Now with carboxylic acid, also we have seen this. Okay, if you're using lithium aluminum hydride, straightforwardly you will get your alcohol. Okay, you will get your alcohol. In order to reduce it to aldehyde, you will use a limited reducing agent such as sodium borohydride. That will limit your carboxylic acid reduction to aldehyde only. Okay. Now, carboxylic acid derivatives. These are the carboxylic acid derivatives. We have acid chloride or acid halide, typically acid chloride. We have anhydride, a strange looking thing with a carbonate with oxygen in the middle, ester, amide, and nitrile. Now, among all these functional groups, you probably are familiar with carboxylic acid and ester only, and most of these are new to you. However, let me tell you that they are not new. You have seen the similarity of things. For example, you have seen acid halide, in the form of its before its junior, that is alkyl halide. So essentially, the difference is just that you are now adding a carbonyl. You have seen, something, it's a junior of amide, it's amine. You have seen RNH2, but you haven't seen it with C double bond O. So the addition of it is just a carbonyl, okay? Anhydride also, perhaps it's very, very similar to ether, very familiar to ether with oxygen in the middle, okay? But right now we have two carbonyl next to it. Okay, so, and we also have what we call as nitrile. Alright, now among all of this, the most reactive one is acid chloride. The most reactive one is acid chloride. So essentially, if you are making an ester, then your acid chloride will react faster than carboxylic acid. So essentially, when we know now that acid chloride has higher in reactivity, therefore, acid chloride will be chosen. If you want to make ester, you choose acid chloride. That means you are going to transfer your carboxylic acid to acid chloride first, and then from acid chloride, you're going to do the reaction. Okay? And you can see our carboxylate is very low in the reactivity. Okay? So, first, we will learn about the naming. Okay, so the naming previously we've looked at the name for typical carboxylic acid, where you just add oic acid at the end, right? Now for ester, what you're going to do is you're going to name the alcohol part first, okay, and then you name the acid part. Okay, like in this case, in the first one, you are adding ethanol to ethanoic acid. Well, this can get a very not confusing, but it's very straightforward because you are looking at both ethyl, right? Now, what you will do actually, you will take the part of ethanol there, okay, and then you're going to combine it with the part here. Okay, you're going to end with the part there. With the part there. So you just cleave out the H2O, alright, and you will get ethyl ethanoate, right? The IUPAC name. In this case, how do you determine? Okay, how do you determine where is your acid part, where is your alcohol part? See, this part right there is the acid part. This part right there is the acid part. That means whatever next to your carbonyl is your acid part. Okay, so the first one you see methanoate, because essentially it is methanoic acid. Methanoic, remember, met means one carbon. And then the alcohol part, you are going to use the naming as 1-methyl ethyl. That means it begins with 1-methyl ethanol. The middle one is phenol and benzoic acid, so therefore you name it as phenylbenzoate. And the next one is methanol and phenylethanoic acid. Okay, so you're going to name it like that. Now the next one, again, the way to understand this is look where is your carbonyl at. Okay, look where is your carbonyl at. Then the one next to the carbonyl is your acid part. That will be your end part there. Alright, that will be your end part there. Okay, in the case like that, 2-methyl propanoate. So you may find more examples. For example, I draw something like that, and then I have something like that, and then I have perhaps something like that, a benzene. Right? Okay, So this part there is my acid. Okay, this part here is my alcohol. So the alcohol part comes first. So you count 1, 2, 3. So it is propyl. And the end there is actually benzoic acid. So propyl benzoate. Okay. So this one's down here is for acid chloride naming. For acid chloride naming. Above there is ester naming. You are going to see many ester, many acid chloride, okay, throughout this video. Okay, for acid chloride, you can see immediately the difference is just this part, oil, oil, oil. Essentially, it derives from OIC, okay, but you're just going to change it to YL. Like alkyl halide, you have propyl bromide, methyl iodide, right? But you are going, in this case of adding a carbonyl, so you just add, you are going to change it to oil, okay? Ethanoyl fluoride, for example, propanoyl chloride. Spell out, the N will be your halide, and then the front one will be your substituents, or not substituent, your carbon chain, okay? So, for example, I have this part, and then I have very simple like that. Then perhaps I want to add a methyl there, right? So you check how many carbons that you have. You have 1, 2, 3, 4. Okay, 4 means but, right? And then you know it is chloride. So butanol chloride. And like carboxylic acid, you don't need to do the numbering for where is your C double bond O at, because it always be at carbon 1, right? But this one, you have a substituent, a methyl substituent at carbon 3, okay? So amide substitution and naming, okay, you have like amine. If you go back to amine, we also have different classification, like this one also. We have primary, secondary, and tertiary. Again, it is very, very similar, whereby you see where is your nitrogen. Okay, if you go back to amine, it's the same thing that I told you. You have nitrogen. How many hydrogen that you have there? If you have 2, then it's primary. If you have none, then it is tertiary. Alright, how are you going to name it? Okay, you are going to see where is your nitrogen. This part here first, okay, this part there, and then you are going to see this part there is our et. So ethanamide, meaning this part, okay, the whole thing there is ethanamide, right? Like amine, okay. So that part there is ethanamide, and then where is your substitution? Okay, substitution at nitrogen. So you're going to spell out N-ethyl ethanamide. Okay. Now this part, how do you determine where is which? Again, look at where your carbonyl at. Look where your carbonyl at, and then count the number of carbons that you have. For example, you have propanamide there. Okay. Dimethyl propanamide, meaning you have you see where is your carbon, C double bond O, carbonyl, and then that part there is your longest chain. Okay, you have propanamide, and then you have methyl at carbon 2. Okay, and then you have other substituent at nitrogen. Now for nitrogen, spell out where is it. Okay, spell it out, where is it? Okay, methyl, and then we have methyl there, we have methyl here, but this one is an ethyl. So this one is quite a strong example. Okay, now something different, anhydride. Okay, not a different one, but essentially what you're going to do is just spell out what we have. For example, like ether, ethyl propyl ether. Likewise here, what you do is just tell whatever that you have. For example, this one you have this met part, okay, 1 carbon, and then you have et part, 2 carbon. So ethanoic, methanoic, anhydride. Ethanoic, methanoic, anhydride. Okay, this one is in the case of where you have both ethyl, not ethyl, that comes from ethanoic acid. So you just say ethanoic anhydride, right? Or in this case, for example, we have trifluoroethanoic propanoic anhydride. Okay, just basically it's like ether, but ether, the end part is ether. Now for anhydride, the end part is anhydride, and then the acid will be spelled as OE. Alright. Now these are the summary that you can look at. This one is very interesting. Name as substituent, very interesting in my case. Alright. So interconversion of derivatives. You see, acid chloride is the highest in reactivity. So essentially, what if you want to make other functional group, okay, you have to use acid chloride instead of say carboxylate or carboxylic acid. Okay, so with this case, then you can see that if I say reaction of carboxylic acid with NH2, for example, with ammonia, for example, I can make amide. In that case, I already learned about synthesis of amide. Okay, so acid chloride synthesis and reactions. We have seen the naming. Remember, acid chloride, the name will end with oil halide. Usually, in this case, is oil chloride. Alright, synthesis of acid chloride. Very simply, like you are making alkyl halide from alcohol. If you make alkyl halide from alcohol, you do ROH, and then you will react it with, for example, SOCl2, and you will get like that. So the same case here, we are going to substitute OH to Cl by reacting it with thionyl chloride. Okay, usually thionyl chloride, and then you will get your product. So because it's the most reactive, see, so there are many reactions that you can do. For example, you can do hydration, and you will get your acid back. Or you are going to do esterification, where you react it with alcohol and then you will get your ester. Or you're going to react with amine or ammonia and you will get amide, you know, and you might want to react it with another carboxylic acid, right, and you will get anhydride. Okay, remember, anhydride comes from 2 carboxylic acid. Okay, you can react it with Grignard reagent, or you can react it to a reduction that you will observe primary alcohol. Okay, I want to correct this one because I think sodium borohydride cannot reduce acid chloride. Okay, it is very selective. It will only reduce aldehyde and ketone. Alright, so lithium aluminum hydride is a very powerful reducing reagent, so it will reduce until alcohol. But if you want to stop it, you can use lithium aluminum, triterbutoxyl aluminum hydride, lithium triterbutoxy aluminum hydride, and you will get aldehyde only. Okay, so now we're going to learn about ester. If you see, the reaction is the same. Ester can make another ester. We call them transesterification. That is reaction. So synthesis of ester, the one that you all know, acid to alcohol. Essentially, everything that reacted with alcohol, either ester and anhydride, you will make acid chloride. You will make ester. Okay, among all, of course, the one that we will prefer is this one because it is the highest in reactivity. So reaction of ester, there are several reactions that you can see there. Okay, among for me the most interesting ones will be the reduction, whereby reduction of ester to alcohol using lithium aluminum hydride, you will get alcohol definitely, you know, and another alcohol because it will not stop until carboxylic acid. Okay, however, if you just want to stop it or to reduce it until aldehyde, you can use DIBA, or I would summarize that as DIBA. Okay, so you will get the reaction to stop at aldehyde. And lastly, something that you already did in the experiment part, that is saponification. Okay, essentially you will get your carboxylate as well as the alcohol. Okay, it will begin with ester. Alright, so now we are going to look at anhydride synthesis and reaction. Okay, anhydride is the one. Anhydride synthesis, we are now reaching the very end of carboxylic acid video and derivatives video. So we have looked at acid chloride, the most reactive one. We have looked at anhydride. We have looked at what is amide, and we're going to look at anhydride. How are you going to synthesize it and the reaction that involve in it? Okay, so with anhydride synthesis, it is essentially a reaction between acid chloride and carboxylate or carboxylic acid. Okay, and you just merge both of them and you will get your acid anhydride. Okay, so one part is coming from the acid chloride, another part is coming from the carboxylic acid. So in the case of acetyl chloride, for example, you just combine acetyl or ethanoyl chloride, combine it with benzoic acid, you will get acetic benzoic anhydride or methanoic benzoic anhydride. Okay, so that is the only one synthesis of anhydride. That's it. Okay, now reaction of anhydride, you have three reactions that you may observe. The first one is hydration, where you just get acid, everything hydrate, ester, carboxylic acid, you will get acid. And then reaction with alcohol, you will also get ester. And lastly, you can also make amide from anhydride, okay, where you will get essentially one amide, another is carboxylic acid. And that is it. Thank you for watching. I hope this video has been helpful for you for your learning, and I hope that you are happy. Bye everybody.